The next reaction that we're going to look at is condensation of alcohols to form esters. But before that, you may be wondering what is a condensation reaction. So a condensation reaction involves the reaction or combination between two molecules to form a larger molecule with a small molecule such as hydrogen chloride, ammonia or water being removed. So in this example, this is a methanol molecule reacting with a butanoic acid molecule. You can see that a new CO bond is being formed between both reactants, but at the same time, the original hydrogen from the OH group in methanol combined with the original OH group from butanoic acid to form water as another product. So the first way we can react with alcohols to form esters is by reacting the alcohol with a carboxylic acid. This reaction requires heating in the presence of concentrated sulfuric acid. So for example, you can see here, I have ethanol reacting with ethanoic acid in the presence of heating with concentrated sulfuric acid to form the ester known as ethyl ethanoate and water. So to name this ester, the first part comes from the alcohol, which is ethanol, so it's ethyl. The second part comes from the carboxylic acid. So because it's ethanoic acid, it will be an ethanoate ester. Secondly, you're going to notice that I use a double arrow for this equation, and this tells you that the reaction actually does not go to completion. It will eventually reach a state of equilibrium. And furthermore, the reaction is also very kinetically slow. So the presence of the concentrated sulfuric acid is necessary. It serves two roles in the reactions. Firstly, it will remove water from the equilibrium mixture, and by Le Chatelier's principle, this will shift position of equilibrium to the right, thus increasing the yield of ester at equilibrium. Next, the presence of concentrated sulfuric acid also provides acid catalyst, or H+ ions, which will increase the rate of the reaction. So this concentrated sulfuric acid, it increases the equilibrium yield of ester, as well as to speed up the rate of reaction. But in spite of this, we still do not generally use carboxylic acids to react with alcohols to form esters. Instead, we try to use acyl chlorides instead. So acyl chlorides have a general structure of RCOCl. You can think of it as carboxylic acids where the OH group had been replaced with a Cl atom. And this replacement makes acyl chlorides much more reactive than carboxylic acids, and they will just react directly with alcohols to form esters. No equilibrium, the reaction will go to completion. So this is also a condensation reaction, except that in the previous example, water was being removed. In this case, when we react as acyl chloride with alcohol to form ester, the small molecule that is being removed is hydrogen chloride gas.